Good afternoon, pre-calculus students. So welcome back to Mr. Chan's master class. Welcome back to my pre-calculus class channel. So let's take a look at that, the continuation with the polar equations, the graph. Okay, so yesterday we talked about that the circles, the line. So after we converted back from polar to rectangular form. And today just want to show you another way to sketch the graph. So the other type of polar function we have is called the cardioids. So anytime they see these things that's written as a structure of r equals a plus minus b sine theta, or r equals a plus minus b cosine theta, where a equals b, so it's going to be considered a cardioid. So the cardioid is kind of like a peach, or it's kind of like a hard graph. Okay, so you'll see that in a minute. So what I got here, so this one is written as r equals 2 minus 2. Well, this one's supposed to be sine theta. That was a little typo right there that I set up previously. So first thing that you want to do, you want to sketch the graph for that sine curve. So imagine that this one is y equals 2 minus 2 sine x. So going back to what we did in trig, it's just like an alternate form, or the standard form of the sine curve, the roller coaster. So back to the alternate form, it's y equals k plus a sine of bx. Okay, so for the alternate form, or the other one is written as k plus a sine of b times x minus h. And then the ultimate form is like k plus a sine of b times x minus bx plus c. Okay, so all those type of form, the one that we did in trig. Okay, so what we found here, so this one is just like a normal roller coaster sine curve, but it's reflected over the x-axis. So in order to find out those position, so we can just say that x is just like theta, and then y, which is r, the radius. So let's find out those critical positions. So started at 0. So when theta is 0, so the radius is 2. So at 0, so the radius is 2. And also at 2, so we do have what? Pi. At pi, also the radius is 2. Okay, so at 0, at pi. And then what else do we have? And then at pi over 2, so this one, the radius, is going back to the pole, because 0, it's the radius. And also with the other positions, like pi over 6, so the radius would be 1. So pi over 6, so the radius would be 1. And also 5 pi over 6, the radius would be 1 as well. So just make it symmetrical. And what about the higher positions? So the other position here at this maximum here. So this one would be considered 3 pi over 2, because that's right between 4 pi over 3, 5 pi over 3. So it's 3 pi over 2, find the midpoint right between. So that would be 4, the radius. So at 3 pi over 2, radius is 4. And also we want to find out the other positions, 3, the radius. So at that position here is right between pi and 4 pi over 3. So then that would be considered okay, so this one is right between pi, 3 pi over 3. So 7 pi over 3, 7 pi over 6. Okay, it's because half of the distance right between, so it's 7 pi over 6. So the radius would be 3. Okay, so 7 pi over 6. So this one would be 3. And then same thing happened over here. So this one is 7 pi over 6. So the next one here, then that would be considered 11 pi over 6. So that position here, it's also considered 3. Okay, so just make it symmetrical. And then the rest of this, so basically we can just connect those dots. Okay, so basically just connect those dots. So it's going to be a cardioid. Okay, the shape. Okay, making sure that this one is plotting the point correctly. So kind of like a heart shape, this one here as well. 2. And this one is just like the extra point that I plotted that incorrectly. So the other one going through this way. Okay, so it's a cardioid. So it's kind of like a heart shape or like a peach. Okay, so like for this one here, you can always check the words. So 2 minus 2 sine theta. So plugging that to the calculator. Okay, so here's what I did. So 2 minus 2 sine theta. And then go to zoom 6. So here's what we found. It's cardioid. And now, what about the other type of graph? So the one that with the inner loop, it's kind of like a cardioid, but it's called the lemicon with the inner loop. Okay, so let's check that out. Okay, so let's do the one with the cosine. So this one is r equals 2 minus 4 cosine theta. Again, so sketch the graph with the standard form. Identifying the amplitude, so which is what, 4 unit. But with the vertical translation, so this one is being shifted all the way to 6. Because 2 plus 4, then that'll be 6. And then all the way down, so negative 2 plus negative 4 plus 2, then that'll be negative 2 for the min. Okay, one cycle. So let's find out all those critical value. So as theta equals 0, so we do know that the radius is negative 2. So negative 2, that means it's being bounced back to the opposite direction. So this one right here. And then at pi over 3, so it's going back to 0. And then at 2 pi over 3, so this one looks like it's all the way up here at 4. And then right between pi over 3, 2 pi over 3. So this one in between 3 pi over 3, 3 pi over 6, pi over 2. So at pi over 2, so the radius, that's 2. So at pi over 2, the radius is 2. Pi over 2, radius is 2, right here. And then 2 pi over 3, the radius would be 4. So 2 pi over 3. So the radius is 4, all the way up here. Okay, and let's see what else. And then the other one is just declining, and then at pi, then that'll be 6. Okay, so at pi, then that'll be 6. All the way over here. So 4, 5, and then 6. So slightly a little bit outer bound. Okay. And then let's see what else. And then this one is declining. So at 4 pi over 3, so the radius is 4. 4 pi over 3. Okay, so 4 pi over 3, which is 240 degree. So somewhere over here. So the radius, once again, which is 4 again. Okay, so over here. And then let's see what else. And then 5 pi over 3, so go back to 0, back to the pole. And then at 2 pi, so the radius would be negative 2. So at 2 pi, the radius would be negative 2. So going back to here. And what about at 3 pi over 2? Let's see. At 3 pi over 2, the radius, 9 pi over 3, divided by 2. So 3 pi over 2 here. So the radius would be 2. So this one, the outer shape, is kind of like a lemicon. The outer shape, it's like a cardioid, but there's like an inner loop in between. Okay, inside, inner loop, inside. So eventually this one is going to sway. Okay, let me just fix that part right there. Okay, so this one should be a curve. Going back out. Going back in. And then right here. So there's like a little loop right in between. Okay. So going outside, the outer loop, and then the inner loop with the cardioid. Okay, so let's check this on the TI calculator. Okay, so the outer loop, inner loop. Okay, so this one, it's the 2 minus 4 cosine theta. Okay, so 2 minus 4 cosine theta. Okay, again, zoom 6. Here you go. So again, outer loop, the peach, and then the inner loop, the little circle right there. Okay? Okay, so now let's see what else that we have for the rest of this. And the next one, it's about the paddle, the rose curves. So for the rose curve, so anytime they see the structure, it's like r equals a cosine n theta, or r equals a times sine of n theta. So the rose has an n leaf if n is odd. Okay, so let's say n is like 1, 3, 5, 7, so on and so forth. So that has n paddle. And if the rose has 2 n leaves, even number, so that means, well, if n is even, so that means, you know, we do have 2 times n paddles, 2 times n leaves. Okay, so let's start out with the graph. 2 times sine of 2 theta. So using that, the basic form from trig, so 2 amplitude down to 2 theta, so that means the period would be considered 2 pi over 2, so it's pi. So half of the distance, so you got pi. So this one is going to be 2 cycle. And we do know that's a sine curve, so that means it's going to be considered a roller coaster. And then half of the distance ran between, so pi over 2. Okay, so right here. So that will be considered the half of a cycle. And then here's another half. And then the rest of that is just a continuation. So pi, 2 pi, half of the distance ran between, 3 pi over 2. And then this one is halfway through. So pi over 2, 3 pi over 2, 4 pi over 2, 2 pi. Well, let's see. Okay, so pi, 3 pi over 2, 5 pi over 2 divided by 2, 5 pi over 4. Goes back up to 2, going back down. And then over here, then that would be 7 pi over 4. So this one is just a repetition with 2 cycles. So going back to trig, what we did last year. Okay, so because that the period only takes pi. Okay, so repetition. So again, follow through that radius theta. So x is theta. So radius, which is y. So as you can see that we started at 0, 0. So at pi over 4, so we do have 2 for the radius. So pi over 4, then that'll be 2. And then down here at 3 pi over 4, so this one is negative 2, 3 pi over 4. So the radius would be negative 2, so that means going down, going back to this direction. Negative 2. And then what else? What about 5 pi over 4? 5 pi over 4 is over here. And this one is positive 2. 5 pi over 4, positive 2. And then at 7 pi over 4, then that's all the way down to negative 2. So 7 pi over 4, but negative 2 reflect it. So it's going back to this way. So you see that this one is just kind of like a vertices for the paddle. So since we do know about the paddle, so this one's going to be going this way. Back to the pole. And then goes this way. Back to the pole. And then this one, it's all the way through. Going back down. Like this. So it's a flower shape. The rose. Okay, so 4 paddles. Again, so if n is, well, if this one is even, so that means we do have, if n is even, so we do have 2 times n paddle. So 2 times 2, 4 paddles. So this one is odd, so it's only 3 paddle. Okay? And then the rest of this, so this one is all about like the random shape or the special shape. Again, so make the graph using that transformations, things that we talk about from trig, standard form, alternate form, ultimate form. Sketch the graph first. So this one, imagine that's y equals 1 plus 2 sine of 2x. So find the period, amplitude, all that, so you'll be able to sketch the graph like this. And also from those critical positions, just read through the graph. So at 0, so the radius is 1. And then at this position here, so it looks like that one is, okay, so this one, it's considered pi over 3. This point here is 7 pi over 12. So this one is kind of half distant away. So 7 pi over 24. Okay. So just plot those points and then you'll be able to sketch the graph. So eventually this one, it's kind of like the paddle curve as well, but with the small paddle here. Okay. So x-intercept, all the x-intercept, that means going back to the pole. Okay, so find out those positions. The radius 3, so 7 pi over 24, so the radius would be 3. So it's all the way out here somewhere. So normally for this type of polar equation, we just want to put into the calculator, because especially once you deal with the special or the random shape. Like this one, 1 plus 2 sine 2 theta. Okay, so just plugging that to the calculator. So 1 plus 2 times sine of 2 theta. Okay, graph. See that? So zoom in. Okay, so it's like one big pair of paddle, back and forth. Quadrant 1, quadrant 3, symmetrical. And then in quadrant 2 and quadrant 4, the small paddle. Again, the radius, so expand it. So pi over 24. Okay, so it's all the way over here. And then the other one is quite interesting. So try to do that on the calculator. So let's see what that is. So the other one, it's theta times sine theta. So theta times sine theta. Go back to zoom standard. It's kind of like an egg with another egg. Okay. So again, if you see any kind of special curve, you know, things that doesn't match with one of those cardioid, limicon, or the rose curve, or any like things that we can convert back and forth. So, you know, normally those are the calculated problem. Okay, so that's it. Thank you for watching the video today. So I'll see you guys next time.